Students in query session Anil Paswan put up a question which is show that the function defined by gx is equal to x minus within bracket x is discontinuous at all integral points. Here x denotes the greatest integer less than or equal to x. Here we have to show that the function is discontinuous at all integral points. So here in this question, we have to keep few points in our mind. Number one, this is the symbol of greatest integer. Greatest integer, right? This is the symbol of greatest integer. If we are going to put any value of x here, so we get the smallest integer, although it is greatest integer. Once again, I am going to repeat the statement for you. This is the symbol of greatest integer. If we are putting any value of x, so we get the smaller integer, although it is greatest integer. For example, if I am going to put 2.35 here, right? So this is greatest integer symbol and our number is 2.35. So 2.35 lies between 2 and 3, right? It is lies between 2 and 3. So as per the statement, we have to take the value 2 here because we are going to take the smallest one, right? Although the word is greatest integer, but we have to take the smaller one, right? Another example, if we have 4.99, right? So greatest integer 4.99. Now 4.99 lies between 4 and 5, right? So we have to take 4 here, right? We are going to take the smaller one. So 4, right? So our greatest integer function is 4.99 and it is lies between 4 and 5. 4.99 lies between 4 and 5. So we are going to take value 4 here. Now let's start solving this question. We have a function gx is equal to x minus x, right? So let's say at x is equal to c, and where c is any arbitrary number. For left hand limit, we have limit x tends to c minus. Now function is x minus within bracket x, and this is the symbol of greatest integer. So it will be limit h tends to 0. In place of x, we have to put c minus h, then c minus h. Now students, notice one thing, that we have c minus h. Okay, and this is symbol of greatest integer. Okay, let's see what will happen. If, for example, if we have c is equal to 5, and I'm going to take c minus h, that means I'm subtracting something where h is very small number, right? So let's say it will gives you 4.99 because I'm subtracting very small number from c, and where c is 5, right? So let's say it will gives you 4.99. So when I'm going to take c minus h, okay, when I'm going to take this c minus h within this bracket, so the greatest integer that of 4.99, right? 4.99. So the greatest integer, while we're talking about greatest integer, so 4.99 lies between 4 and 5, right? Lies between 4 and 5. So we have to take a small number, which is 4. Clear? Right? So 4 will be taken out. In another example, let's say if c is equal to 6, so c minus h is just nearly equal to 5.99. So for greatest integer of 5.99, greatest integer, this will lies between 5 and 6. So we are going to take a small value, that is 5. That means for greatest integer, we are going to subtract subtract, that means we are going to take c minus 1, right? We are just taking c minus 1. We are subtracting 1 from this c. Here we have c is equal to 5. Okay, we have c is equal to 5. So we are going to take 4 here. Here we have c is equal to 6 and c minus h is equal to 5.99. So according to greatest integer, we are going to take 5. Similarly, we are going to apply this one here. So we get limit h tends to 0, c minus h minus c minus 1. Okay, again I am going to repeat this, right? If we have c is equal to 5, then c minus h, that means we are subtracting the smallest number from c. So we get 4.99. So the greatest integer c minus h, and c minus h is 4.99. So it will give the value 4, because 4.99 lies between 4 and 5, and we have to take the smaller one. So 4 is the smallest one, right? So we have to take 4. So we can conclude that 5, if we have c is equal to 5, so our greatest integer, right, we are going to take 4. So here we have c minus h, that means we have to minus 1 from this. We have to just subtract 1 from this. So we get limit h tends to 0, c minus h minus c minus 1. On taking limit, we get c minus c, okay, then minus minus plus 1. So we will left with 1. Now for right hand limit, we have limit x tends to c plus, right? Now our function is x minus, within bracket x, this will gives you limit h tends to 0. In place of x, we have to put c plus h, then c plus h. Now again we have to understand an important concept here, right? If we have c is equal to 5, and if I'm going to take c plus h, so let's say I get 5.001. Now when I'm going to take the greatest integer, so 5.001 lies between 5 and 6. So our smallest number is 5, right? 5 is smaller as comparison to 6. So we will get 5. So that means if we are going to add any small number in c, so we'll get c as it is. For example, if we have 6 here, so then if we are going to add a small number here with 6, so if c is equal to 6, then if we are going to add c plus h, we get 6.001, and this will lies between 6 and 7. So we get 6. That means we get the c same, right? So we can conclude that limit h approaches 0, c plus h, and this will reduces to, yes, c. On taking limit, we get 0. From this, we conclude that our left hand limit is not equal to right hand limit. So this is what we have to prove that, right? So one of the most important thing you have to keep in your mind while solving these kind of question is that the concept of greatest integer, right? The concept of greatest integer, right? If we have for example, c is equal to 5, as we discussed in the part, right? If we have c minus 5, so that means if we are going to take c minus h, we will left with 4.99, right? If we are going to take its greatest integer of 4.99, so 4.99 lies between 4 and 5. So we have to take the smallest number, right? 4. So students, I hope that you understood this concept. Now we have next question. We have to check the points where the constant function fx is equal to k is continuous. Function fx is equal to k is continuous, right? So the function is defined. The function is defined at all real numbers, at all real numbers, and by definition and by definition its value at any real number equals to k, right? So let's say c be any real number. Let's say c be any real number. Then limit x tends to c of fx is equal to limit x tends to c. Now fx is k, right? So k is equal to k. Since f of c is equal to k, so we can say that limit x tends to c fx for any real number, c, the function f is continuous at every real number, okay. Once again I'm going to explain you this question. The function is defined at all real numbers, and by definition its value at any real number is equal to k. Let c be any real number, so limit x tends to c fx is equal to limit x tends to c k. So this will gives you k. Since fc is equal to k is equal to limit x tends to c fx for any real number c, the function f is continuous at every real number. Students, I hope that you understood the concept. Okay, till then, thank you.